how we will how we can classify with using of the remote sensing applications, and later you convert into the digitalization part, and those in a digitalization part we will classify where it is that build up area or agriculture land, how we can identify, and the agriculture land it is also classifying like uh, kharif cropland and rabi cropland, or sometimes maybe it is classifying as a um, availability of resources. We can use that is as a double crop land. So plantation zones follow land, forest land, wastelands, and the water bodies and other formations also we have seen we classified on image. Today we are going to discussing about 19th unit, uh, that is the remote sensing and GIS applications in geosciences. Yeah, the geosciences applications in remote sensing and GIS. Yeah, actually, the geosciences applications are playing the very important role in the remote sensing and GIS. We'll collect the data from ground truth based. Those the data details we should compile, and we should create a framework. We have to follow the one process according to field areas which are having a different geological materials, geological formations, and we'll follow the geological methods for obtaining the data. So here uh, first we will require the data in a multispectral and hyperspectral ranges from optical regions through the thermal region and microwave region also. So to improve the spatial resolution. So here, the application point of view, we require the images, and there the image interpretation elements also required for that purpose. The image interpretation elements like tone, color, auto color, texture, the pattern, uh, shape, size, shadows, sight, and the association. These will be playing a very important role to find out the different structural. And as well as here we can study the terrain elements also. The terrain elements means here drainage patterns, the density of a drainage, topography, and erosion of a status of a particular area. The area maybe it is a soils erosion, or maybe it is a soil, or maybe it is a rock erosions. This we will see. Yeah, here there are some applications are there in geological point of view. Yeah. These the applications mainly we can see the mapping of a superficial deposit or bedrock. Whatever yeah, superficial deposits here the deposits which are formed on a surface, and bedrock formations also. The bedrock formations means like basement granite maybe, or maybe it is sometimes we see the sedimentological formations, or sometimes maybe we see the metamorphic zones also. Yeah, lithological mapping. Second one, it is a lithological mapping. The lithological mapping here, the lithology we will find out. Lithology means the process, the formation of a rocks. The study it is known as a lithology. So here the lithological studies means the formation of the rocks and how they were arranged on a surface, or what are the type of rocks are there. Those we can see like a granite terrain, how it was formed, and what are the compositions in that lithological compositions. Maybe suppose if you can see that is the granite, the composition of a granite we will study, and the formation. Lithification means here formation, the composition of a granite, what does it contain, and those compositions we see the different mineralogical components are there like in a granite we will see the quartz, feldspar, biotite, and muscovite mica. And sometimes we see these veins, allanite and uh, chlorides. These minerals are there in the granite composition. So here, these are the minerals we need to find out once if you are taking the photograph of a particular area, uh, whatever our target area. So there we will get the color indications in multispectral data, or maybe it is a hyperspectral data, whatever it is that the color it is indicating the different minerals are there, and those colors we should identify, and we should identify the colors, and according to the colors we'll create a map. So that is one case. Structural mapping. The in a structural mapping here it is explaining that the formation of different structures on a surface, like faults, folds, and different small fractures or joints and lineaments. These structural features basically in a geological words, in a geological terms. So the faults, how they are forming. Faults means the separation of a separation of a two rocks. Um, the or we will call the major fractures were created between the two rock formation. Those will be separated from one to the another. A fold means the rocks or a terrain. It's containing the bending or curvature nature, curvature nature. Joints means a small displacement between the two rocks, small displacement, and anyway those are having the relation to the one rock to the even though displacement, but it is having the small relation between the one rock to the another, or one formation to the another formation. It is known as a joint. Yeah, lineament, it is a small fracture on the surface, rocky surface, or the lineament, it is indicating the line, and the line, and it is showing the variation from one rock to the another rock. So here the lineament extraction also we will identify, and another one it is mineral exploration. Here the mineral exploration, there are various types of minerals are there on a earth, within the earth and above the earth. So here we need to identify the new minerals with using of a different color pans. So once if you are taking the photograph on a surface, and those will be moved to one place, to those will be identified on a image in different colors. So according to the color variations or tonal changes, we can here with using of those tonal identification, we will identify which mineral it is expecting the which color. So the color, maybe it is the false color composition, or sometimes maybe it is the real colors also there. So the real colors we will unable we are unable to find out clearly. So that we will add the false color compositions, because of the false color compositions which are identified near the infrared rays, so that near to the infrared rays, the color will be reflecting from the original colors to the false color. So based on that colors we'll identify, there are some indications are there. According to that indicators we will identify the new minerals, and which is useful for exploration point of view. In the same the exploration purpose, hydrocarbon exploration, that means oil exploration, uh, oil extracting, where it is the oil seals are there, and those will be indicating in a different pattern. So pattern color also. So in oceanic studies also, in ocean basin areas also, these oil um, formations or oil exploration studies which are identified on a image interpretation image interpretation. Next one, environmental geology. In environmental point of view, the application types of geology, and as well as the remote sensing and GIS. These will be useful. to extracting the environmental data like mining areas. We will select the example for mining areas. In a mining areas, yeah. In a mining areas, the in a mining areas, we will establish the different types of silos and silos like industrial settlement as a setup will be arranged there. So the smoke will be releasing from that one. The impact of a smoke into the atmosphere and the impact of a smoke in a environment. So how does which is showing in a different color while it is releasing to the atmosphere the smoke. So we will take or we will capture by the remote sensing those image and releasing those images and it's giving the different color so that the color variations will identify the what are the polluted gases are releasing from that danger gases or pollutant gases will be releasing into the atmosphere. We will identify with using that. So now based on the studies or data analysis and finally we will give we will give the suggestions and which is not suitable for these areas and it is not suitable for different purposes we will inform. Yeah, next one, geobotany. Yeah, in a geobotany applications, here we will take the photograph in a certain areas or certain terrain. So there we can see the image elements. The image elements, the arrangement of a uh, texture. So here the texture, it is discussing or giving the information about the tonal changes on the image. Suppose the mineralogical areas, if you can see, the according to the biological properties, I mean, will in the respective of plant leaves, those plant leaves are exhibiting in a different color because of the mineral content. Maybe if it is high there, so it automatically it is consuming through this root, and it will enter and settle down into the plant bodies. So that on the plant leaf surfaces. So that leaves which are absorbing the sun rays, and while it is absorbing that, it is, and at the same time, it is few amount of energy it is reflecting into the atmosphere. Then at the time if you are taking the photographs or images or if you're taking the uh, flight survey or airborne survey by the satellite, so that the satellite it is releasing the energy, either it is maybe active sensors energy or what is the passive sensors, so whatever it is that. So in the presence of those sensors, it's reflecting the energy and the color it is maybe different. The mineralogical property, the mineral if it is available in that plant leaves, it is absorbing by the plant leaves, maybe it has a different color. So that once if it is exhibiting into the atmosphere, while it is moving to the one place to the another, it will be releasing in a different way. So that the color variations are different. So that is the reason. Based on that indications and the tonal color, tonal changes will be there. The texture it is also will be different at the time. So that is the one of the basic points. Based on that, we will identify the yes with that plants are having the mineral resources, and the plants it is indicating only indicator. It is showing the indicator whether the mineralization zone, whether the minerals are there or not there. We will identify. So final one it is mapping and monitoring here. In your mapping and monitoring the areas whatever we are collecting from the different sources. According to that source, one minute. According to that source, we will create a map based on the ground truth data. We will collect. We will see the image and images, the images which are having different properties. and different properties, and we will upload it into the GIS, and later we'll fix the geo coordinates, four sides of the coordinates of the image. So these are four sides of the coordinates of the image. We will see the geo rectification and geo registration. Later we will add the features. So what are the ground truth features? What we have extracted? What we have extracted from the different areas? Those data we will incorporate in that. We will incorporate and we will update the data. So these are the main application point of view we can see with using of a remote sensing in earth sciences. Just we will go back and we'll come. So here the image how they are playing the important role in extracting of different uh, surfacial features. Here the images we will extract from a multispectral sensors. Yes, definitely we will use here multispectral sensors, and which are having the great prospective and essential means the applications in different field of geology. It's like the first we can see the area of a map. The preliminary investigation of a mapping depend on their scale types, and later we will study the geomorphology. We will see the geomorphology. What are the geomorphological features are there? Those we can see, and structures and lithology. The structures, different types of structures. In further, I'll tell you what are the structures we are going to study. And lithology means here the formation of a rocks. The formation of a rocks. Different. There are three types of rocks are there: granite, yeah, igneous formation, sedimentary formation, and metamorphic rock. These three types of rocks are there, and the formation of a rocks which are having the different rock types are having are containing the different minerals. So the minerals which are exhibiting the different colors on a image while it is moving the passive sensor on a particular surface where we have selected the area. So the lithology it is giving the information the types of a rocks. What are the types of the rocks are there? The application point of view, these maps which are useful for to various fields. So we will see the geo-environmental purpose, and various projects will be released into the mineral exploration point of view, and the geotechnical projects. So in that case we will use in a large scale. In a large scale so large scale means real regional area study, but not local. In a regional area study purpose, these air force studies or air photo studies or airborne surveys which are useful, and which is really which the equipments we will use the sophisticated equipment, and those will be giving the information uh, perfectly. Yeah, but there is a less applicability of a remote sensing mapping in your geology. If terrain, if it is filled with deep forest areas, sometimes maybe it is soils, or sometimes maybe it is land covers. According to that, so so It is a very less applicability in older days, but actually now we have a lot of data. Now we are using remote sensing applications of remote sensing in geology. Because why it is a less means here the area maybe if it is covered with a dense forest, or sometimes maybe it is covered the land area or soil area, whatever it is that it is covered by the dense forest. So if you are taking the photograph or if you are taking the if you are applying the remote sensing applications there will run the satellite from one area to the another area there maybe there maybe facing the problem while it is releasing into these the waves or the energy into the surface from the satellites which are observed by the plant leaves and there if it is a thick forest zone area, so what is happening, it is unable to find out the formation of a different minerals on surface or surface of soils or maybe on rock terrains because of the light if it is not a fall on the light waves or radiation waves, whatever it is, maybe that which are not fall on a surface only. It is absorbing by the plant leaves in the thick forest zone area. So that is the reason we are unable to find what type of mineralization it is there on land or within a rock composition. So that is the main defect from application point of view in forest zones. So the mapping of a geology, it is basically done on the exposed rock structure like road cut, river, and other vertical section. Yes, definitely. Particularly if you are getting the any doubt whether that area it has a mineralization zone or not. So what to do for that purpose? So here we will do the excavation, deep excavation. So that what is happening, we will get the formation of different formation of the rock types there. So the surface, this soil types also we will get. The formation of a soil types also we will get. So that's where we will see these type of features, the soil features or rock terrain features. We will see where it is getting the road cutting areas or excavation, or maybe it is a vertical section of soils. There we can see. So those pictures or those studies we are unable to see in that cuttings only in that maps, but only the road cutting we will get the information, but vertical sections we are unable to get to there. So maybe that is one, it is a defect we can see. Yeah, here whatever information, necessary information we will prepare on a map based on the image collector from the remote sensing. So here the applications of the remote sensing has been increased manifold after the development of sensor technology. Yeah, definitely we can say here there is a scope and there is a source and there is a availability of a different techniques and availability of a sophisticated instruments are available at outside. With the using of a different sensors, we will get a clear information in a particular area or in a target areas. For the field of lithological mapping based on the uh, mineralogy and hyperspectral images are very important to application of these things. In a hyperspectral image which contains a large array of spectral responses with a narrow interval and contiguity, contiguity to able to detect the minerals based on their spectral responses. Yeah, and definitely later I'll show you those pictures to you. Right. Yeah, you see here. Actually, it is showing the lineament patch, this one. But anyway, you see different, suppose if this is a 3D modeling of image, 3D model image, the hill areas, you can check this hill areas and the down portion between these two hill areas, the valley it is forming. In the down, it is showing the arrangement of a formation. This is the basement here. This is the basement, and it has a mineral resource. It is getting the reflecting. You see here in the basic colors of RGB, red, green, and blue. The image what we are using 3 to 1. So here the mineralogical point of view. Yeah, these are the colors which are indicating the availability of minerals. So it is actually in the first picture it is showing the list one maybe image because of it is showing a black and white color almost, but the color reflection are different. Color reflections are different here. So here our intention it is that to find out the minerals, to find out the minerals. Suppose if it is the forestry area, maybe it is a hill area, it has a forest, thick forest. So that the flight maybe it is moving through this one, or the satellite maybe it is moving through this area above the hills. So it is releasing the radio wave or electromagnetic energy onto the surface, electromagnetic waves, which are having a different lengths, wavelengths. So maybe it is not fallen on the surface because of the complete energy absorbing by this plant leaves only, absorbing by this plant leaves only. So that is the major cause. We are unable to find out what type of rocks are there on a surface. So this is the major. This is one type of defect in a particular area. So that's one thing. Yeah, next one. Yeah, the identification of features, the geological features. It is based on the variation spectral signatures of elements help in a geological mapping. How does these geological features, which are useful for to making of a geological map, that means here different structures of geological features which are showing the different colors. So according to that, based on that color indications, we may identify, and the pattern associations also will playing the very important role here. Here, so according to that, we will identify the what are the fracture zones are there, and yeah, what are the fold formations are there? Those we will be used, and based on that, we will draw a map. The thermal remote sensing data in geological mapping. Yeah, here the depend on the rock type. Depend on the rock type. The geological mapping, the thermal response, maybe it is a vary. Depend on their temperatures and formation of because of different rock types are forming in a different temperature. Example, granite, igneous rocks. Igneous rocks means at outside, generally we see the granite rocks. Those granite rocks are formed at a high temperature level. So at the time, the temperature maybe it is different. While it is taking the photograph, it is using of a thermal remote sensing data. Suppose thermal remote sensing means it has a huge amount of a temperature there. So the image, if the image will be the image will be seen in a different color while we are using the thermal infrared thermal uh, mapping. So the temperature maybe it is different, so automatically we get a different data. In a night time, if we see the night time, the image, if there is a high thermal inertia, the signature of a rock brighter and vice versa. So here in a night time, what's happening? If you are using the thermal application or thermal radiation, the thermal infrared, in the presence of thermal infrared, if you are applying that on a rock composition, then the original light will be released at the time. And in the presence of that, what are the, suppose if it has any mineralization, it is exhibiting the different colors. So the image also we can see it is in a more in a bright color. So that is one thing. And next, yeah, the lithological mapping, it is using by the remote sensing applications. The lithology, it is science, the formation of a rocks and characteristics of a rocks. The remote sensing technique, which is used highly in these studies, because of we may find out the nature of a rock, and what are the uh, parent elements are there in a rock formations, and what is the internal structure and molecular structure to be identified with spectral signature studies in the same rock compositions. And suppose if that rock, if it is having any iron composition or manganese, copper, nickel, chromium, these elements we can identify in a nearer infrared region. Uh, in near infiltration, or sometimes maybe the same rock composition which are having the hydroxyl ions, carbonates, and water molecules, we will identify in a short wavelength infrared region. So here you see here some of the elements we will identify with use in the presence of a ultraviolet rays also. So the color it will be changes in the presence of a light. So we will use short wavelength and long wavelength of light ultraviolet rays. So there, fluorite, apatite, blue, apatite, scheelite, these minerals sometimes we see it is in a blue color in a ultraviolet rays. Calcite, calcite depend calcite, and that is also we can see it is in a blue color. Blue color. According to the structure and arrangement of minerals, the colors which are exhibiting. So according to that color, we will identify it is so and so mineral. So the abundant of rock forming minerals, like example silicates, oxides, nitrates, and nitrites, phosphates cannot be recognized in the reflected region 0.4 to 3.0 micrometers of electromagnetic spectrum. Because of what is happening, the silica oxygen or silicates and oxides, we are unable, those are not having the absorption capability. So those are not responding because of the internal structure. It is different of a different elements. So that is one of the major reason those are not absorbing the ray colors. So, we are unable to find out it is belongs to which color. So that we can see those in a dark or gray color. We can see on a image. Microwave remote sensing data, how we can apply in geological mapping. The microwave range of the electromagnetic spectrum, it is used by the imaging different radars. Maybe that is 1 centimeters to the 1 meter uh, ratios. The information we will get shape the orientation. The surface maybe it has a roughness or a smooth surface complex, and the synthetic aperture radar will be also used. The valuable information about a geological terrain like a surface roughness. Yes, definitely. The terrain, maybe it has soil terrain, it has a coarse grain texture, or maybe it is a medium or a fine. So the roughness, if it is, we can see it is in a coarse grain texture. So the arrangement of a textures, the formation of a texture and texture of the soils, those we can identify very easily with using of that. And sometimes maybe the soil moisture we will identify the topography and drainage patterns which are provided by the uh, SAR. SAR. And he was the person Gupta. He was identified these characteristics. He was studied. And the synthetic aperture radar, it's also providing the information about the in-situ rock type and subsurface structure. Yes, definitely. The in-situ rock types and as well as the subsurface structure, the internal structure of internal structure of earth and surface. It's a which is providing by this microwave studies, microwave remote sensing applications, and as well as the cursor relation resolution data. It's also providing by the synthetic aperture radiation techniques or radar techniques, where minor information and variations are suppressed. So we will use the microwave remote sensing data here, the arrangement of a geological terrain or a formation of a geological terrain, and the whether the soil which are having the smooth formation or rough formation. Those we will identify, and topography and the drainage patterns. Different types of drainage patterns are there. Those drainage patterns will be studied with using of these microwave remote sensing data. Some structural mapping. The structural mapping. We will study the attitude of beds. Different formations are there. The different formations are there. Different layers were lead to formation of a bed, and which having in a different direction and dip and a strike. The strike means it is a horizontal formation of a rock, or a horizontal formation of a rock, and on, onto the parallel to the surface. It is known as a strike. It is known as a strike, and as well as the inclination of a bed, it is known, the amount it is known as a dip. So what is the importance of this one here? The strike, it is speaking about the arrangement of a rocks on a surface and uh, parallel to the surface. The arrangement of a rocks which are having the horizontal formation and parallel to the surface. So finally, it is showing the arrangement of a rock formations directions. And next, the bending nature and the rock, it has an inclination angle. The inclination angle, it is known as a dip. And the inclination angle, it is known as a dip. So here, by the analyzing the slope, symmetry, landforms, drainage characteristics, or the value of a dip or angle amount of a dip, which can be identified using the visual interpretation satellite. So here the figure, it is showing the strike slip part on aerial photograph. It is from the Las Vegas. Just you can see, these are the beds. You see, these are the bed means the rocky terrains which are forming continuously, and there is a small fault, slip fault. Slip means it is um, movement. One rock, it is a one rock, it is a mode on another rock, and the gap it is a forming here. The formation it is known as a slip. This one. So it is a moves towards down. This is move towards down. Actually, the formation it should be like this. So uh, due to the slip, it's a move towards down. The gap it is showing this a fault, slip fault it is showing. So here the land forms the formation of a land on a surface, and it has a different properties and the drainage characteristics also which is showing. It is a parallel drainage. It is a parallel drainage pattern. You see here, it's a parallel drainage pattern. Now you can see. So the drainage patterns we can identify. Yeah, the folds by yeah, yeah. Mm. The folds, it's a plunging and non-plunging refolded folds which can be identified on the satellite data. The various types of folds will be there. Here, there is a parallel bed in a non-plunging folds, U-shaped outcrop pattern in a plunging folds. We may identify the deep direction of a different folds, different beds, which can be used for further classification into plunging, anticline, syncline. Oval-shaped outcrop pattern is produced by the double plunging poles. Noise of the plunging poles are surrounded by the major stream curves. I'll tell you about this. The recognition of a pole's first thing it is. How it will ID poles on in particular rocky terrain. Just you can see here. Here you see the different. This is a hill area. This is a hill area. So there is a gap between the from this terrain to the this terrain. So here one valley was formed, and at the same time, I'll show you please in the fold. Structure. I'm searching for a structures. Wait. on this one. Yeah, now you can see here this is the outcrop of the formation image. This structure you can see bending curvature. This is the bending curvature nature. It is known as a fold. So how it was formed? This is the due to the pressure. The both sides of pressure will be worked. You see here, the force will be worked out here, so that the bending curves or bending formation will be seen on. You can see on a rock. So the pressure it will become from this side and as well as this side while it is crystallizing or forming. So the shape it is look like it's a different. So the structure it is known as a fold. The curvature structure it is known as a fold here. So these type of foliations we can see, and you see here the compressional force. This one based on that this force two sides of force two sides of force will be working on this formation or rock formation whatever it is that while it is in a sol middle stage of a solidification, then the force will be applied, the rock it is getting the bending. So previously actually it was like this, and slowly the pressure will be applied in both directions, in opposite directions, then slowly the bed it is getting this strain. This is the bend will be forming like this. It is forming like this. So again, I wanted to show you one. Now this. Now what I told you, the strike, the arrangement of a bed. This is parallel to the surface, and where the this is the strike line, and the rocky terrains which are forming. This is, you see, these are the beds. These are beds are arranged on a surface. This is a surface maybe. So the strike, it is indicating the formation of a beds which are forming parallel to the surface, and it inclined towards surface. If you feel it is a surface and inclined towards surface, so it is showing the inclination, this angle. The inclination angle, it is known as a dip. So what's important to us? So here you see again the dip formation. This is the surface and the rock which are formed above the surface. The strike direction is different. So it is inclined here. This line and this one, this line. This is the surface and the rock formation, this one. Here it is creating the angle. So this angle, it is known as a dip angle. So these are the Brundtland compass, which is useful for measuring of dip and strike. Yeah, this is the geological map what we will draw based on the surface features. It is a cross-section map of a geological map, the particular area what we have identified the surface of the contours, the contour lines, which is indicating these contour lines, it is indicating the elevation and the height of this hill. So if we do the cross-section, this one, like, so we will get this measurement or this structure. Yeah, this is the fold. This is what I wanted to show you. So these foliations or bending curvature we can see on a rocky terrains. This bending curvature, it is known as a fold. So it has a, if you can divide into the two parts, this line, it is known as a hinge line fold axis. Along this fold, you see this fold here, fold, it was done. So if you are creating one line, the line, it is known as a hinge line, and these two parts are known as a limbs. The bend parts, whatever the curvature parts, whatever we'll call, it is known as a, or we'll call this a limbs. So between the two limbs, that means between the this curvature, it is known as the axis. It's the axial plane. So no need those all, but actually for a knowledge purpose, I am telling to you. But in a remote point of view, this the past picture what we have seen. This is important to us. The outcrop what we are seeing. Outcrop means the outside whatever rock formations are there above the surface, or rock fragments or surface above the surface. The rocky parts what we are seeing, those are known as outcrops. Okay, this, you see, this is a image. Suppose if you are taking the photograph by the satellite with using of different sensors, so it is showing the beds. Different beds are there. The beds are having the folding nature. This is known as a fold. Yeah. Wait, again, we'll go back. Yes. So here, depend on the formation of folds, the oval shape fold, shape folds we see, and linear feature here. The linear feature, it is showing the lineament or small fractures or faults on a surface. You see this one, it is a major lineament because of the major displacement between the two rocks. Suppose if it is a continuous, if it is a continuous rock, or you see this is a continuous rock, but small gap was there. The small gap was found here. Small gap it is showing as a lineament. Small gap. After some time, what is happening due to the movement of plate tectonics, or the Earth, it is always rotates. We know that. So the rocks maybe it is getting the divide and far away from one to the another. So that the gap, more gap will be creating while it is moving in the opposite direction, opposite direction. So slowly after some time pass, some time means me, it will take thousands of years, or sometimes maybe it is taking million of years. So the fault maybe the gap was created, the huge gap was formed. The huge gap is known as a fault. It is known as a fault. And small displacement will be there between this one, like you see this from this one row of outcrop, and this is one crop, small displacement. But anyways, there is a relationship between two. So the gap it is known as here joint. And very small displacement will be there, or a fracture will be formed. It's known as a limit. Okay. So in a mineral exploration point of view, how these remote sensing will be applicable. A remote sensing point in a mineral exploration point of view, uh, which is useful for to find out the new minerals, to find out the new ores. Ores means it is a more content of a mineral in a rock. It is known as a ore. Suppose example for if you are seeing this previous image, this image you can see here. This example telling you, yeah. In a RGB basic colors, we don't know what are the minerals are there, but here there are a way in a physical component analysis. We see a map, we can see different colors. We apply the multiple colors and multiple colors. So this area it is showing this one, this crack. You can see this lineament. It is showing. It is showing something variation. So here also it is showing something variation. And the greenery light, sorry, this thick green, and sometimes we see it is mixing of yellowish color, and maybe it is indicating the forestry areas. So this one, the lineament, it is the lineament or the red color, it is indicating the, maybe it is a mineral source. Because of it is a lineament. The lineament, it has a chance to fulfill of a minerals or whatever it is that. So according to uh, this, we may identify the availability of the minerals here. So in a mineral exploration point of view, in a mineral exploration point of view, the minerals, how we will identify the minerals, whether that area it has the minerals or not. So here we will use the multispectral data and the multi-temporal characteristics we'll study with using of the remote sensing data. The means the mineralization zone, if it has the rock mineralization zone or minerals, it is exhibiting the different colors. The different colors we can see in a in exploration and evaluation and genesis of mineral deposits. It can be done on a high spatial and spectral resolution data for remote sensing. The application point of view, which the mineral which started about 16 years ago. But actually, because of why we are mentioning 16 years, only later independence, our searching is started. Our applications were started on a mineral exploration point of view. So that before that also we are having the minerals, but actually we are unable at the time. We don't have a such type of a technology. and those at the time we are not we don't have knowledge about the particular minerals. But anyway, we have a mineral resource, plenty of mineral resources in our country, but lack of knowledge and technical lack of technical knowledge, we are unable to find out where the minerals are present. Later, the technology was developed, and we are using the different applications on a rock formations, so that we will get little bit of a mineralogical resources or mineral resources on a particular area, depend on their the satellite image study. So here, almost in first two stage of mineral exploration, what we will do first? First, we will do the area selection and target the target to area. We will apply the remote sensing or remote sensing, and the platforms the platforms which can apply to updating the data. So here, these spectral signatures, the hyperspectral signatures, which are useful for to find out the alteration zones related mineral deposit, can be identified based on the spectral signature. Um, yeah, that's maybe multispectral sensors, or maybe sometimes you use the hyperspectral sensors with using of the airborne scanners. The airborne scanners, the scanner is scanning the data, and if any mineralization zone or alteration zones, alteration means to change. Alteration means to change the color, or to change the area where minerals are going to be changes to one color, one mineral to the another mineral. How they will change depend on their factors, the chemical factors we applied, the chemical elements in the presence of a high temperature and a pressure. The water molecules will be reacting with the same chemical elements. Then automatically, which are in the presence of a high temperature, the alterations will be done. The chemical compositions will be changes. Example for if you see the laterite. The laterite, we can see it is two types of laterite. One, it is alumina laterite, and second one, it is iron ore laterite. In a iron ore laterite, in the oxidation and reduction process, the water, if you can apply, or the water molecules, maybe if it is more available in a iron oxide, so it is getting the oxidized, and the color will be changes in the presence of a water molecule. So the chemical composition is going to be changes there. So that is the reason the secondary iron ore minerals is forming in a laterite deposits. So in a laterite, it is a composition group of minerals, or the group of elements are there, like iron, silica, alumina, calcium, magnesium, potassium. These elements will be there. These elements will be there. Oh, in the but the main component, it is iron. Iron, it's getting the oxidizing in the presence of a water, so that is the color composition will be changes. In that, uh, the alteration means here the original formation, original composition, or original mineralogical composition will be changed. Once if it is a done, color composition will be changes. Those will be seen on a image. So that's the one thing. That is the one thing we will apply. Yeah, we will use these studies in a hydrological point of view. In a hydrology, we will identify the water zone areas and water target area, water availability areas with using us of these applications. The hydrology means study of actually it is a hydrology and hydrogeology. Hydrology it is the science to study of your waters, different types of your waters, whether that area it has a forest zone or agriculture zone and land cover areas, whatever it is. So the availability of water, and types of water we can see in a hydrology. So the salt water, it is giving the different color composition, and the pure water, it is giving different color, and the forest areas also, it's also giving the different color compositions. So naturally we can see the color, we can of a color water, you can see it is in a blue color, but that is depend on their deep level of the area. Some those deepest area of water zones we can see it is in a dark blue color, or a dark blue color, or a surface area we may see it is in a, sometimes we see it is in a green, because of the fungus, more fungus will be formed, algae and fungus will be formed on the surface water. So that is the reason the we can see that areas of water in a green color, but naturally the water we can see it is in a blue color. Blue color. Those studies also we can identify with using of these remote sensing applications. Here it is showing the multi-spectral image for the identification of different minerals. You see the alunite, the red color it is showing the alunite, and green color it is showing the muscovite. Maybe suppose it is a rocky terrain, it is a rock formation. You see this is a target area, and it is having different colors. The red color maybe it is indicating, the red color it is indicating this one, this red color it is indicating as a alunite mineral, and the green color you should see here, this complete the green color it is showing availability of muscovite, white mica, and the calcite, the limestone material calcite, this the calcite, and kaolinite, the kaolin mineral, the yellow color it is showing the kaolin mineral, and the pink color it is showing silica, this one silica, this is. So different minerals are there, we can see with you in a multispectral image. With using of a multispectral image we can see there are various types of wavelengths depend on their base wavelengths bands. We can use here 13, 12, 10, and red, green, blue color. The green color you see it is a vegetation area, red it is showing the rocky terrain areas, and blue it is water bodies. So different, it's a valley formation, and here you apply the sharp wavelength infrared 4, 6 in the RBG. The same area you can see it is in a infrared. The green color it is showing the red color here. This green color showing here it is in a red, and blue as it is it's showing the same. And the mixed composition you see it is in a mixed composition. Maybe it is a saline water zone area, so that is the reason can see it is in a mixed composition. These are all the lineaments, the rock formation, the lineaments are showing with a digital elevation model to apply the GIS. And here it is a dome or a canyon, so not dome, it's a canyon type formation. It's a 3D modeling of surface area. The blue it is indicating the water zone areas. This gray it is indicating, you see here this gray color. It's a hilly areas, and the copper mine may be somewhere here if the work is going on. The plan, the mine plan. So here the hilly areas terrains are now this a fault, and this blue it is the fault alluvial formation we can see on surface. Yeah, now you see here in the same 3D model, different minerals are there here. It is showing in different colors: breccia, conglomerate, evaporates, or gneisses. Different minerals are showing in a different color. So here the color composition will be applied. This is a open pit of a copper mine in Arizona, North America's place, the most copper producing area in the world, in the southeast Arizona, in the North America. So this is a mine, and beside this area you see forest zone. This completely. The photo was taken by the land satellite, and this is a copper mine area. It is showing. Okay, oil spills. Here we can use to identify the oil exploration, oils also, oil and gas. This is the fault. We see these oil formation zones. We will identify in a sediment formation, in sediment zone only. Okay, why only radar? It has a capable to detecting the oil. Radio and detecting ranging. Here the radar means radio and detecting the ranging. It has a Bragg scatter. Bragg's depend on it will be working and a Bragg's principle. So the clean sea area show the spatial deviation waves fulfilling the Bragg scatter. So here we will use the radar satellite. The radar satellite, it is sending the waves into the oceanic water. There dispels if it is available. The radar has capability to travel into this clean water. So somewhere area, this area it has a oil zone. This is the small fracture you see with the line. It is showing the source for the oils. Okay, once it download into the image, we will create the 3D modeling. We will create the different layers in a GIS. In a GIS, where this where it is producing the or oil points, or where the sources will indicate like these lines, and we will apply on a surface in a 3D modeling. And this is actual surface zone area, and this is a map what we created on a GIS, and this is the original land features. Okay, you see here oil spill monitoring, oil areas. The image where the areas oils which are having it is showing this indication on seas. This one. Okay. Okay, in a groundwater point of view, you may identify the water zones. So suppose if you see on a water areas on a image, the most basic areas we can see in a brown spots we will identify on a image. Those brown spots are filled by the water. So just suppose if it is a fractured rock, just I'll show you and a Okay, now you see this image. Actually, it is a Google map. Uh, yeah, various formations are. We can see this is a completely. This is a hill area. It is showing what it is, that it is indicating the hill area. It is a dike formation. Yeah, the water application point of view we are searching. So actually, this is a completely drought area of this one. You can see this image. It is indicating the plants. This is a completely plantation zone, thick forest zone area maybe. The brown spots be there somewhere. This is a brown spot. It is not a just this one. The color maybe it is a different to compare with this one. So this type of a brown with mixing of a gray. This color, this is indicating this point. Maybe it is indicating the water zone areas. But here somewhere here small tree it is also there. But beside this one, this point it is indicating the water point. How we can say that? We will. I'm not telling that tentatively, but it's a real point. We have applied in different areas and we got success also. Okay, this is so some way it is different. You can see a small fracture, a small line, the lineament it is going on through this one and joining here. So the little bit of gray and a brown spot was created here. Maybe if you can drill here, you'll get your water. So this is a one. Just only I'm telling you example, and according to that, we may find out the uh, groundwater exploration point of view. We'll identify the groundwater also using of this one. Okay, now you see this is a Sagar area. Why I'm showing, you see this is a, it is showing the different patterns, different lineaments and drainage patterns which are showing. Yeah, this rocky terrain area where I wanted to show you one thing. Chitriala, yes, this area. Okay, some little mineralization zone. The copper mineralization zone we identified here with using of same remote sensing technique. Actually, it is showing the blur, but wait for some time. Maybe it will be shown. Uh, this one it is a hill area. The formation, whatever it is, showing the side. Also, you can see this. It's a completely hilly area. Okay, these zones, the formation zones, it is a little bit the color variation. It is having a different. You see the brown color. It is showing almost. Maybe this area it is indicating this area. This area is indicating the availability of a copper mineral along this formation. It's a complete unconformity we will call. Along this unconformity, we may identify little packet holes. Uh, so the geological applications are different while using the remote sensing. This data will extract the photographs and images and will upload it into the in your GIS tool desktop, and there you can apply. You create the layers. You create the layers and you update the things whatever you have extracted from the field data. So yeah, different drainage patterns also there. We'll identify the this I'll explore it from the perspectives. Yeah, JS applications we see in yeah for a water resource purpose. Yeah, yeah. This JS in a water resource purpose. We will extracting the data where we are going to updating things. The JS data we will create association of geographical features with compilation of uh, ground truth data. Ground truth information we are having in our hand, and we will compare with real data. So here, in a remote sensing application point of view, whatever physiological feature, physical characteristics obtained from the image in a target data, we will integrate with the GIS. So the applications give us in the application. So here we will develop the urban plan and rural farm sectors and water and water management, land management, and navigation. So in a JS through remote sensing applications, we'll allow the network analysis of large areas and section of subsets, detailed analysis, it is having the a distinct spectral properties, water absorption radiation depend on that radiation the water will be absorbed. It will be reduction depend on their depend on uh, composition of water body. So here we will apply the main basic planning and what is the irrigation the study will also carried out, and rainwater harvesting and other recharge water harvesting pits where we will create it, and flood forecasting management and watershed management, groundwater quality and groundwater management, quality assessment is also carried out to the people will enhance water and data with these parameters. And finally, where the saline water is available or the pure